I guess it's week 9, so this week we're looking at just 2 lessons. We're looking at 101 and 102. So let's go ahead and jump right in. Lesson 101, translating expressions into equations. So this is something we've really been doing all year, even if you don't realize that's what you're doing. Sometimes the way it's worded, I think, is a little confusing. So if we see these things, let's at least have talked about them. So twice a number. I would say 2 times a number, but if we say twice a number, we can represent as 2 times a number. 5 more than a number, again, I'd probably just say plus 5. 3 less than a number, so that number minus 3. Half a number, that number times 1/2 or divided by 2. The product of a number and 7, and I just say 7 times a number, but 17 is, so equals 5 more than twice a number. So twice a number, and then 5 more is equal to 17. So let's look at example 1. If we have 5 less than twice a number is 17. So we have 5 less, so we know we're going to be subtracting 5. Twice a number, so 2 times a number is 17. So we have 2n minus 5 equals 17. And then what is the number? So we're just solving for our variable. We've been doing this all year. Inverse operations, minus 5, so I add 5. And then I divide by 2 because I'm multiplying. That number is 11. And again, we could plug it back in here, make sure it works out. The left and the right side are equal. It would be, so we know we did it correctly. A taxi company charges $1.50 plus $3 per mile metered at tenths of a mile. Write an equation that relates the total fare F in dollars to the number of miles of a taxi ride. Then use the equation to find the fare of a 6.4 mile ride. Okay, so M, number of miles, it's $3 per mile metered at tenths of a mile. So we go down here, fare is F, so that's where we get this, equals 3 times the miles, because it's $3 per mile, plus 1.5, because $1.50 we have to pay no matter what. If we go 1 mile or 100 miles, we're paying that up front. So that's a fixed cost that we can't get rid of. So for 6.4, once we have our equation, $1.5 or 1.50, doesn't matter. We're going to put in for 6.4. So we know our destination is 6.4 miles away. We want to figure out how much we're going to be charged. Okay, well, let's plug in our unknown. We now know 3 times 6.4 is 19.2 plus 1.5 is 20.7, or $20.70 is what we would call it. Okay, so once we have the rule, then we just put in our input and get our output, just like every other function we've worked with. The big thing is making sure that we read the problem correctly and put in all the information correctly. So if we did 1.5 times m plus 3, mix up those numbers, that's going to throw us completely off. The angles marked x and 2x in this figure are supplementary. Was the measure of the larger angle? Okay, so draw our own. Imagine these lines are straight, so we have x and 2x. And when we know this angle plus this angle have to add up to 180 degrees because it's a straight line, they're supplementary, so 2x plus x equals 180, so that's 2 plus 1 is 3x. And we divide by 3, Now, be careful, don't we get here and we know, x is equal to 60. Yes, but that is not our answer, so we're not quite done yet. We want to find the larger angles. We're going to plug 60 in for x. So this larger angle is 120 degrees. That is our answer. So sometimes we just assume, oh, we found x, we're done. We're almost done in this example because the larger angle is 2x. So we know x, plug it in, 2 times x, or 2 times 60 is 120. Now we're done. Okay. All right, that practice set we will do together. So let's look at transversals and simplifying equations for lesson 102. In a transversal, we have parallel lines cut by a transversal. We've talked about this, but angle 1, 4, 5, and 8 are all going to be the same. All of our obtuse angles are going to be the same measurement, and then 2, 3, 6, and 7, all of our acute angles are going to be the same measurement. So what's nice about this, and there's names for alternate exterior, alternate interior, corresponding angles, vertical angles, a lot of different names for the positions of the angles, but if we remember, all of our acute and all of our obtuse are going to be the same. We can be given one angle and pretty quickly find all the other 7. So if we're looking here, and A is 105, well, I know A plus B or A plus C, either way, have to add up to 180. So I know B has to be 75. So now all of my acute angles, A, D, E, and H, are all 105, and then B, C, F, and G are all 75. So it makes it nice and easy. There's only 2 different angle measurements. Or the one rare case where they're all the same, because if these were 90 degrees, it would be 90, 90, 90, 90, 90, 90, 90, 90. So if it's the transversal is cutting the parallel lines perpendicularly, then they would all be 90. Otherwise, we're going to have 4 acute and 4 obtuse angles. Okay, as we said, corresponding angles, so those are the ones in the same position. So like G and C, they're from the intersection down and to the left, down and to the left. So those are corresponding. Or F and B, up and to the right, up and to the right. So those are corresponding. Alternate exterior, they're exterior, so they're outside the parallel lines, and they're on the opposite side of the transversal. So A and H, G and B. Alternate interior angles inside the parallel lines, so it's C and F, opposite sides of the transversal, inside the lines, D and E. Okay, so those are names for those. So if we want to go through and name corresponding angles, 1 and 5, 2 and 6, 3 and 7, 4 and 8, alternate exterior, 8 and 2, 1 and 7. Name 2 pairs of alternate interior, well, 4 and 6, because they're inside and on the opposite, and then 3 and 5. So it makes it really nice. Simplifying equations, we can combine like terms, and to combine a like term, they have to be the same variable or unknown to the same power. So like x squared and x, we can't combine those by adding or subtracting because we don't know what x is, and x squared are not the same. And we can always move around equations, treat it like it's all addition, and then rearrange so that way we can combine like terms. So if we're looking at example 3 here, sure, still recording. Okay, good. 5, 3x plus 5 minus x equals 17 plus x minus x. Okay, so let's just start with any combination on the left or the right that we can do. Well, x minus x, I know that. Any number minus itself is just 0. We have 3x minus x, so 3 minus 1 is 2x. I can also subtract 5 from both sides. 2x equals 12, and divide by 2 to get x equals 6. Okay. So if we look here, we have 3x plus 2 times a binomial. So we have to distribute, multiply 2 by both of these terms equals 32. Let's take a look at that. So 3x plus 2 times x minus 4 equals 32. So again, I'm going to distribute the 2 in there first. First thing would be parentheses, but I can't do it because x minus 4, two different terms. 2 times x, 2 times negative 4, so it's minus 8. Still equal to 32. Okay, I can combine these. 3 plus 2 will be 5x. I can add 8 to get that to be 0. So 5x equals 40, then divide by 5, and x equals 8. All right, practice set we will go over together. And then we'll do lesson 103 next week.